Now you gotta start charting.
Yeah. Okay, operations on functions. We're graphing the f plus the g function. So we're going to start a chart here. Certain x values, the f function, the g function, and then we'll do what are the values when we add them together. Okay, so first of all, the domain, so -2 for both of them. And 1, 2, 3. So this one goes to 7, and this one goes to 4, so I do have to stop at 4. That's what my chart's going to look like. Okay, so let's do the f function here. So a height of -2, -1, 0, and then 1, 1, 1, 1. The g function, we are at 0, then we're at 2, and then we're at 4. 3, 2, 1, 0 are the heights. Okay, so when we do this plus this, -2, +1, a 4, a 4, a 3, a 2, and a 1. Okay, so when I pick my coordinates, I'm looking at that and that. So -2, -2, -1, 1, 0, 4, 1, 4, 2, 3, 3, 2, and 4, 1. Connecting them all, and there's no arrows because these do not have arrows. Okay, so we're going to do a subtraction function. So what are the values of f of x? What are the values of g of x? And what are the subtracted values? Oops. F of x minus g of x. Okay, so that order obviously matters. The domain 1, 2, 3, 4, that is a -4. That is a -4, so I can start at an x value of -4, and the farthest right is 2 and 4, so this is the farthest right I can go. So my domain is -4 to 2. Okay, so the f function, I'm going to take these y values, so -2, -1, 0, 1, 2, 3, and 4. Those are the heights. The g function, the height is 1, 2, 3, 2, 1, 0, and then 1, 2, 3. Okay, so we're going to go the f minus the g. Make sure that your order is correct because subtraction would matter. So -2 minus 3, -5, -3, -1, 1, 1, 1, 1. Okay, so I'm going to graph these coordinates. So for instance, that coordinate is -4, -5. And I'm going to continue in that pattern. So 1, 2. There's the first point, and then -3, -3, -2, -1, -1, 1, 0, 1, 1, 1, and I have to stop my domain at 2. And there's the graph. Okay, we are given the graphs of the f function and the f minus g. We have to graph the original g. Okay, f of x, g of x, which we don't know. And then this is the subtracted. Okay, so our domain, we're going from a 1 to a 4. So that's the domain. So the f function was at 5, then 3, and then 6 and 6. We subtracted here, so this height is 1, 2, 3, 4, 2, 2, and 2. Okay, so what would we need here? So 5 minus what would have given me 4? So 1, 3 minus 1 would have given me 2, 6 minus 4, 6 minus 4. So my coordinate would have been 1, 1, 2, 1, 3, 4, and 4, 4. Number 4, we're going to sketch the multiplication function. So the f of x function, the g of x function, and then the multiplication function. Okay, so our domain here, that one's negative infinity, but we have to restrict it here. 1, 2, 3, so negative 3. And we can go to infinity, both of them. So we will just do a few to show you that that's going to be an arrow, that domain. Okay, so let's pick some points from the f function here. So at negative 3, it's at 0, and then 1, 2, 3, 4, 5. The g function is at 2, everywhere. So when we multiply, so 0 times 2, 0, 2, 4, 6, 8, and 10. So this pattern will keep going. We got to remember that there will be an arrow there. Okay, so we have the coordinate negative 3, 0, negative 2, 2, negative 1, 4, 0, 6. I can already kind of see what's happening. And then we remember on this one, there will be an arrow because they both have a domain to infinity. Okay, we're going to sketch a subtraction function for number 5. So here's the f function, the g function, and then we have to do the subtraction. We're going to have to look at the order on that one, remember? Okay, so the domain, 1, 2, there's a negative 7 and a negative 4. So the furthest left I can go is negative 4. So negative 3, negative 2, negative 1, 0. And the furthest right I can go is to 2. Okay, I'm going to pick some values here. So the f function, we're at negative 1. Oh, this is not a perfect. I'm going to go with like a 0.5. Maybe I won't even use that one. Negative 2, comma 2. Negative 1, comma 1, 2, 3.5. 0, 5, 1, comma 6.5, and 2, comma 8. Okay, so maybe we won't use some of those. We don't always need to go every single point. Okay, so the g function at negative 4, so 1, 2, 3, 4. We're at 4, then we're at 5 and 6, and then we go back down to 5 and then 4, and then we stay at 4. Okay, so be careful the order. So I'm going to have to do this, so 4 subtract, like that, 4 subtract -1. That's what I'm doing, so that's 5. 5 subtract 1/2 is 4 1/2. 6 subtract 2. 5 subtract 3 1/2. 4 subtract 5. Okay, so again, my coordinates would be -4, 5. -3, 4 1/2. Okay, I'm going to continue this pattern, so -2, 4. I'm going to graph maybe every other one here, so 0, -1, and 2, -4. Okay, so connecting that, and that. Number 6, I was given this graph, x minus 3, and this graph of x plus 1. Sketch the graph of the multiplication. Okay, so let's go the f of x, the g of x, and then the multiplication of them. So they both have infinite domains. So we just are going to pick a few. So why don't I go with a -2, -1, 0, 1, 2. Okay, doesn't matter. I'm just going to graph 2 and see if I can find a pattern. So -2, 1, 2. So -5, -4, -3, -2, and -1. The g function, so at -2, -1, 0, 1, 2, and 3. So if I times them, order doesn't really matter when I times. So 5, 0, -3, -4, and -3. So let's graph some coordinates. So -2, 5. -1, 0. 0, -3. 1, -4, and 2, -3. Do we see any kind of pattern? Yes, this is going to be a parabola. And I'm guessing that would be the next point, and they will have arrows. Okay, both left and right. I also know that algebraically, if I do times that, it would be x minus 3 times x plus 1, which is a quadratic. It has x-intercepts at 3 and -1. So that also lines up with my thinking. Number 7, an addition function. So the f function, the g, and the addition function. So the domain, -3, -3, so we can start both at -3. And then this one goes to 2, and this one goes to infinity, so I have to pick from to 2. Okay, so the f function, the heights, so at -3, it's a 2 height, a 1, a 0, 1, 2, 3. The g function heights are 0, 2, and then 2, 2, 2. So if I add, don't even need to look at the order, adding doesn't matter, so that adds to 2, 3, 2, 3, 4, and 5. So I'm going to graph these coordinates, so negative 3, comma 2, negative 2, 3, negative 1, 2, 0, 3, and then there's a 4 and a 5 height. So my pattern will look like that, and I do have to stop. Even though this has an arrow, that one doesn't, so it has to stop. Number 8, I was given the two graphs. Sketch the graph of them multiplied. Okay, so my domain will be able to start at negative 1, and I have to stop for that. So 1, 2, 3. So that will be my domain. Let's do the f function column, a g, and then the timesing column. Okay, so the heights of the f function are 1, 2, 3, 3, 3. The heights of the g function are negative 2, negative 2, negative 2, and then the next height is 0, and then 2. Timesing order is okay, doesn't matter, so times makes a negative 2, negative 4, negative 6, a 0, and a 6. So my coordinates are going to be negative 1, negative 2, 0, negative 4, 1, negative 6, 2, 0, and 3, 6. Okay, so connecting the points will be that. And there's no arrows because there's no situation with two arrows. Number 9, I was given the graph of the multiplication and the g, so sketch the f function. What is the f function? The g we know, and the multiplication we know. The domain, we're going to go from 0 to infinity. Okay, so I'm going to start with 0. Okay, so we don't know the f, so let's write the g. So at 0, we're at a height of 1. And then 2, 3, we're just going up here. When we multiplied, we ended up with a 1, 2, 3, and then a 4, and then a 3 height, and then at 3, we're at a height of 0, and at 4, oh boy, here we go, 4, we're at 1, 2, 3, 4, 5, we're at a negative 5. Okay, so what is this column? So what times 1 makes 3? What times 2 makes 4? What times 3 makes 3? What times 4 makes 0? What times 5 makes negative 5? So here are my coordinates. So 0, 0, 3, 1, comma 2, 2, comma 1, 3, 0, 4, negative 1. Since this is an arrow and this is an arrow, we're also going to have a right arrow. Okay, number 10, given the f and the g, sketch the addition function. Okay, so the domain we have to restrict at negative 2, and then they both go right, so we will go from negative 2 to infinity. I'm going to pick those values, but we do keep going. Okay, so the f, I'm going to go with the heights, so negative 3, negative 1, 1. At 1, we're at a height of 3. 2 comma 5. Now looking at the g function, the parabola shape, so at -2, it's here at 3, -1, 0, 0, -1, 1 comma 0, and 2 comma 3. So when we add, doesn't matter the order, so that added is 0, -1, 0, 3, and 8. So I'm going to graph these coordinates, so -2 comma 0, -1, -1, 0, 0, 1 comma 3, and 2 comma 8. And then I will have an arrow on that side because those both had an arrow on them. Number 11, we were given these two graphs. Do the subtraction graph. So order matters when we subtract. So the domain, we would have to stop at 0 because this one only goes to 0 on the left, and then they both have arrows to the right, so we can keep going. So 0, 1, 2, 3, 4, I'll pick that, but we do keep going. So the f function, so 0 has a height of 1, and then we're at a height of 3, then we're at a height of 5. Okay, so we're obviously going to be going up by 2s there. The g function, 1, 2, 3 is the height, then 2, then 2 comma -1. Okay, so hopefully that gives us enough to do a pattern here. Now f, so I got to do this. So 1 subtract 3, so -2. 3 subtract 2 is 1. 5 subtract a -1 makes 6. So here's my coordinates. So 0, -2, 1 comma 1, 2 comma 6, okay, so the shape is going to have an arrow continuing to the right. Number 12, given these, determine the value of the f times the g at -1. So we only have to do one thing on our table here. So at -1, the f function is at a height of -1. And at -1, we're at a height of 1, 2, 3, 4. So if we multiply, it is -4. So that is the answer. That's the value. In number 13, we are given these. Determine the value of g function minus f function at -3. Okay, so just at -3, okay, so at -3, 1, 2, 3, the f function is at a -2. At -3, the g function is at a height of 1. So order matters. So I have to do the g minus the f. So that gives me a value of 3. So my answer is 3.